Good afternoon, everyone. My name is Ramesh Gopinath. I lead the HP, SAP, COE, and Tech Ops Management team. And these are my Amazon colleagues who are going to present.
Okay. Good afternoon, everybody. My name is Ritwish Dave. I'm a Senior Solutions Architect at AWS. Excited to co-present with my colleagues today.
And good afternoon, folks. My name is Vasu Senkavaram. I'm a Senior Manager of Solution Architects here in AWS. Now, customers worldwide have opted to migrate, modernize, and operate their mission-critical SAP workloads on AWS. Due to the various benefits that AWS offers, right? The scale, the variety of services, security, and reliability. Now, if you're already on your journey to migrate and modernize your SAP footprint, your SAP workloads, and would love to hear from HP, a global technology leader who has successfully migrated and is operating their mission-critical workloads in AWS, then I think you have a lot that you can learn in this session. Now, in this session, we'll share how HP has scaled their mission-critical workloads, especially SAP, on AWS. We'll go over its current state on AWS, including a recent transition to RISE on AWS, which is the managed offering from SAP. We'll go over the drivers behind HP's migration, including business imperatives and the technical requirements. We'll dive deeper into the architectural patterns, which we think will be very useful for all of you, including scale-up and scale-out architectures, high availability and disaster recovery. Now, we've also wanted to share with you the timeline about how HP's landscape evolved, right? It wasn't just a one-step move, so we think that that will be very useful for you. And last but not least, we really want to share with you the key lessons learned in this journey and give you some of the best practices and strategic considerations that will be useful for your migration. And to get us through this, I would like to invite Ramesh to go over HP's journey.
Thank you, Vasu. So those of you, most of you should know HP. HP has been a household name for now 85 years. Formed by two gentlemen, Bill Hewlett and David Packard, in a garage in Palo Alto many, many moons ago. And it's evolved over the years through many different iterations and formations. Today, if you look at HP, there are two main product lines from HP. One is their personal systems, which covers essentially everything from PCs and laptops for consumers to those being used by corporations, and even to gaming PCs and other kinds of personal devices. The personal systems division also covers Poly, which is the workforce collaboration tool, which can be used, we use it for, our headsets and other devices such as that, and also for office collaboration and for teaming and things like that. The other main line of products within HP, as everybody knows, is HP printers. If you look at this particular slide, just moving on, if you look at the different KPIs of key figures for the company, how has HP's SAP system evolved over time? Given you're an 85-year-old company, SAP has been with HP since the early 2000s. And so when you look at that, ultimately HP, around 2017, went into a strategic program called Simplify, and as the name suggests, was meant to standardize on global business processes across the company. To look at a typical sales cycle, if you look at the opportunity to the quotation piece, to the order management, fulfillment, etc. The intent was to come up with those various global processes that would run on these SAP systems. So the intent would be that we would migrate off of those 14 different environments to a single global S4 environment with multiple SAP systems in that ecosystem. Around 2020, we migrated to AWS as we started scaling and having growth requirements that we needed to be more agile. We'll talk more about why AWS came to set for us in the upcoming slides. We ended the transformation around 2023, and then around the first quarter of 2023, from our March-April timeframe, we decided to start our migration to SAP RISE. SAP RISE migration took roughly around a year, and we were done with that this year in 2024 around March time. Ultimately, if you look at it in terms of the number of systems we have, this is again not the full. If you look at the number of systems we have today, it's about 450 to 500 or so. EC2 environments, some over a petabyte of data storage-wise. It's a system that continues to grow, and I think growth, not unlike many other companies, we've done, I think, a good job in moving systems quickly, consolidating it from 14 or 15 environments to single environments, but we've been a little bit behind the curve on data archiving and data reduction, so that's why you will see the growth in the systems. In terms of the business processes running on these systems, as I said, everything from the order management piece all the way, if you work your way through the process to your quotation, through your sales piece, through your deliveries, billing, financial documents, etc. All of that runs within these SAP systems, including logistics and warehouse management. And the other aspect to this to think about is that we also have reporting in terms of our BW systems having the data that comes out of these main S4 and ERP environments. And we'll talk about that in the upcoming slides. This number here, this key figure here is regards with our S4 system. One of the things why it's so crucial for us, I think different companies have different strategies of maybe distributed S4 environments or ERP environments. We went with a single ERP environment, and today that single ERP environment runs 90% of our revenue that I was showing you in the first couple of slides. In terms of database operations, we run about 120,000 database operations, and that's on an average. I think during peak times, during month ends, during holiday volumes, we run close to about 150, 180,000 database operations per second, and that roughly translates to about 500 million transactions per year running through these systems. So, all that being said, where did we land up in terms of our systems? So this slide is a little busy, but let's start in the middle of it where you see the main systems in RISE, and these are the systems that we migrated to SAP RISE, S4 being in the center of it all. As you can see, we had multiple systems around S4 that went to RISE. So altogether, we moved about 14 landscapes to RISE. Each landscape consists of dev, QA, pre-prod, prod, right? So 14 times 4 in most cases. And below that, if I work my way anti-clockwise to the left, we've been growing our footprint on the BTP, and for various reasons, right? Whether it's related to clean core, whether it's related to process insights, etc. There are multiple services on the BTP that we are using today, and we continue to grow that. If you work your way down from there, we are not just using applications and systems in the SAP private cloud, but in the public cloud space as well, like Ariba, integrated business planning, SAP Analytics Cloud, etc. Right? And then continuing to work my way to the right, we have SAP non-RISE private cloud systems, and these are systems that we have either decided not to migrate to RISE for certain reasons, or they're probably going through some transformations like our GTS system. Today, we are migrating to GTS for HANA. So we're going to finish the migration for GTS for HANA and then move to RISE. And then to the right-hand side, the bottom right-hand corner, you see systems like OneSource and the B2B systems. OneSource is our use for tax calculations. Like some of you might use Taxware or Vertex and things like that. We use OneSource. And there are other systems in this group of systems that eventually talk to the systems in our warehouses. And then last but not least, moving up to the upper right-hand corner, is we have the various warehouses, data warehouses, and then the other SaaS solutions like Workday and ServiceNow. Now, the drivers for modernizing our SAP workloads. I would say if you look through it, the business drivers, it's not really different from many other companies. If you look at what we needed to be able to standardize our business processes in a quick fashion, be able to do that in a relatively short time. If you think about it, 14, 15 ERP environments in less than 3.5 years, time was of an essence, and being able to grow and expand and contract as quickly as possible was key. And being able to do that on a scale as we start rolling out by country, by business unit into that single ERP environment, consolidating systems. And then all this while this is happening, we still had mergers and we still had companies coming in. We still have some today that we have to work through and get into this platform. So all of that, our key business requirements as from a business standpoint, they want this to be done seamlessly for a good reason, right? For they want to focus on the strategic value they give to the business. And to do that, if you think of the business drivers, those translate to the technical drivers, which is, the ones that are pretty clear on the right-hand side, right? You're trying to reduce technical debt, improve your scalability and reliability, and when we went to the cloud, being able to use all the HA capabilities in the cloud, being able to use a DR across different AZs and regions, all of those native advantages you kind of expect with the cloud is what we wanted to leverage, that we felt made the most sense for us to meet our business requirements. And then last but not least, I would say that, to be able to do this pretty much with a skill set mix that, over time, I think our teams internally grew into those skill sets, and they grew into learning how to use these environments in AWS, and we leveraged what we already had in AWS because we had other systems that were outside non-SAP systems in AWS, and a pretty big footprint at that, right? So it made sense for us to keep going in that direction as well. Moving forward, I think I'm going to give this to you.
So you had mentioned, Ramesh, that HP already had various key non-SAP workloads already running on AWS.
Yes.
And HP and Amazon has had a strong relationship. Right? It's a very strong relationship where HP and Amazon the AWS team has been supporting HP in terms of making sure that the workloads are what we call as well, right? To make sure that they're cost optimized, they're reliable, they're secure. And so that all of that said, right, that seemed like just table stakes and kind of a me too.
Yes.
Ramesh, the question to you is, what caused HP to actually choose AWS for your SAP workloads?
As you can imagine, those 14 or 15 ERP environments that I referenced earlier, over the years, they were in our HP data centers, right? So, and as we were already starting to use AWS for some of our other capabilities, and we could see and leverage those native cloud abilities, as we also partner closely with SAP, obviously, given the size of our environment. And the SAP certifications on AWS for systems running in AWS, whether it's operating system, whether it's database, were key for us. And so when we started when we started to look at a cloud provider that made sense for us, not just like Vasu said, from a standpoint of we have other systems that are closely coupled with these SAP systems, and therefore, would you go with a cloud provider that you're already comfortable with, that has the capabilities that you have? It made the most sense. And also AWS worked with us in terms of the migration credits and some of the other features that they usually work with other customers, and that really helped us move quickly as well, right? And they could bring expertise, like people like Rutvich, for example, that when you needed the SAP expertise which was AWS nuanced, not just SAP, but SAP on AWS, then they brought people like Rutvich that we could work with, solution on the fly, and ultimately I think that's sort of helped in our decision making.
Next up, now that we've gone over the business drivers and some of the journey, I want to hand off to Rutvich to walk us through some of the architectural patterns that HP has used, and hopefully it will be useful for you as well.
Okay. Thank you, Vasu. So as Vasu said, we'll now go over the architecture patterns and scaling workflows adopted by HP for their SAP systems running on AWS. Now, when we think of SAP landscapes that run today, especially with systems like S/4HANA and BW for HANA and other systems, there are two main components that make up the systems. One is SAP Application Server, and other is SAP HANA Database. Now, when we think about scaling SAP Application Server or scaling SAP HANA Database, there are different architecture patterns that we follow, both for scaling and both for deployment of these components. And these architecture patterns are scale up and scale out. Scale up refers to taking a component running. Am I audible? Okay, so scale up refers to running a component like SAP HANA or SAP Application Server on a single server or a single instance, and then you resize the server or instance as you need. And scale out refers to taking a component like SAP HANA or Application Server and running it on multiple instances or multiple servers. And as you can see, HP has adopted both scale up and scale out patterns in their SAP landscape. Now, Ramesh earlier mentioned about Simplify program, which engaged consolidating multiple ERPs and discrete business processes that made up those ERP systems into a single SAP landscape that's based on systems like S/4HANA, BW for HANA, et cetera. So as a result of the consolidation and growing or evolving business demands, the data volume and processing requirements grew in systems like S/4HANA, BW for HANA, and MDG. So in order to meet the growing requirements, HP had to periodically scale the systems. And in the last 4 years, HP successfully completed 15 unique scaling events for the SAP HANA database deployments that support the systems. Now, these HANA database deployments run on Amazon EC2 instances. And 13 out of 15 scaling events were scale-up events, in which the SAP HANA database deployments that were running a scale-up architecture on EC2 server were scaled using EC2 instance resizing. So the sizes of the EC2 instance were increased in order to provide more capacity to the SAP HANA database deployments. And the remaining 2 scaling events were scale-out events, in which an SAP HANA database deployment running a scale-up architecture on EC2 instance was re-architected to run a scale-out architecture on multiple EC2 instances. Ramesh, do you want to speak about the correlation of data growth in the systems that led to scaling activities?
Yeah. So, as we were decommissioning the older systems, the old ERP environments, and adding into the main S4 platforms, I mean, S4 itself is the main central system naturally. It is, of course, surrounded by an ecosystem of master data governance, BW for HANA, SLT, GRC, et cetera, a whole lot of other systems. So for us, data-wise, we were, as I said, I think the focus was really to move the systems as quickly as possible to the new environment. Archiving would come later. And if there's one lesson I would take away for everyone who's starting on this journey, or maybe you've already been on this journey, is that archiving needs to be, the data lifecycle management needs to be front and center right from the beginning itself. Because it's hard later on as you come in to kind of pick that up and try to get it up and running, because by then the data has already grown much quicker than you expected, right? No surprise. So no surprise, the data from the main S4 system, we replicate that using SLT to the BW for system. And so as S4 grows, BW grows as well, right? Sometimes, in fact, when we archive data from S4, we have requirements that the data should not be, the deleted data should not flow into BW. So BW still continues to grow. So that's why you see the different scaling events that Rutwich is referring to. And the good thing is we've, again, worked with AWS, whether it's through scale-ups most of the times, but scale-outs, which we'll talk about in the coming slides. But we've managed to make it work thus far. But I think main lesson here is, make sure you have a solid data lifecycle archiving strategy in place.
Okay, thank you, Ramesh. So as Ramesh mentioned, right, now let's look at the scaling workflow. So here we'll look at the scaling workflow for an SAP HANA database deployment that's running as scale-up architecture on Amazon EC2 instance. So when you have to scale an SAP HANA database on EC2 instance running a scale-up architecture, how do you do that? Typically, customers do that by resizing the EC2 instances. This workflow is followed by HP and many other customers that run their SAP HANA scale-up architectures on AWS. So here, we have an SAP HANA scale-up deployment running on EC2. We have two databases running on 2 different EC2 instances, because this is a highly available deployment. So we have primary database running on its own EC2 instance, and secondary database running on its own EC2 instance. And we have determined that we need more capacity. So the first step is finding the EC2 instance type that is going to give more capacity, but it is also important to know that we'll have to find the instance that is certified to run SAP HANA workloads. So we find the instance type, and here with this particular instance type, which is certified to run SAP HANA workloads, we have 896 vCPUs and 24 terabytes of RAM. So it offers us greater capacity than what we already currently have. So the next step is to provision these instances. Now, these are high memory instances. So you typically work with your AWS support team to provision these instances in the AZs where you want them. So after provisioning these instances, we are ready to start the workflow to resize the EC2 instances. So the first step we take is that we shut down SAP HANA database on these instances. The next step is shutting down the EC2 instances where the SAP HANA database was running. And then we can access the AWS Management Console or command line interface, and we can change the instance type to adopt the new instances that we just provisioned. Then we start the new instances. We start SAP HANA on the new instances, and once SAP HANA starts, it is ready to serve the end users and applications. Ramesh, do you want to speak about some additional considerations that your team followed when they executed this workflow?
Yeah, so when we started this initially, it was learning experience, obviously, where we partnered with AWS, and then we kind of got pretty good, I would say, on it. It became almost a non-event for us as we started scaling up. But I think in the process, what we also forgot was that as you go to the bigger size boxes, the best migration path is always to have the target machine in the same AZ. Then the downtime is sort of minimized, and the amount of sort of the data that has to be transferred between data centers, that's not an issue, right? It's within the same AZ. Now, if you go and wait, and for example, recently we had a case where we had to go from an 18 terabyte BW system to the 24 terabyte systems. We made that decision pretty quick. We didn't sort of plan it well enough in advance, and in that case, we had to do a migration across AZs. Not necessarily impossible or difficult thing, but it just takes longer and it takes more planning, and therefore you got to be prepared and ready for that. So I guess the main thing I would say is make sure you forecast in advance or forecast as much as you can of what you need capacity-wise, especially as you get to the bigger size boxes, because that way, you're not sort of having to migrate across AZs, and it just makes it much more seamless and transparent.
Okay, thank you, Ramesh. So now we'll look at the scale-out workflow. This workflow was followed by HP when they had to take an existing SAP HANA scale-up deployment and convert it to scale-out deployment. So here we have an SAP HANA deployment running a scale-up architecture, and it's supporting mission-critical S/4HANA application. And HP had to take this deployment and convert it into a scale-out architecture. So the first step in the scale-out architecture is to figure out the number of instances or number of nodes that are going to make up your scale-out architecture. And second step is to determine the sizes of the instance and instance types that are going to make up the scale-out architecture. So once you have determined the number of instances that you need in the scale-out architecture and the sizes of the instances, the next step is to provision the scale-out architecture. And by provisioning, you provision the EC2 instances, and then you also run SAP HANA on these instances. And you will notice a couple of things here. One is that these instances in scale-out architecture are provisioned as cluster placement group. That is important because we want to minimize latency between these instances. And then you will also notice that the leader node in the scale-out architecture is currently scaled as bigger than the other two nodes in the scale-out deployment. And that is for a reason, because when we are doing the data transfer, we are going to do the data transfer from scale-up database to the leader node in the scale-out database initially. So once we have the instances provisioned, the next step is to establish the SAP HANA replication link between the scale-up database and scale-out database. And when I say scale-up database, the leader node in the scale-out database. And then we begin the data replication. Once the data has been replicated, we distribute the tables across the nodes in the scale-out database. And once the data has been distributed, We don't need the replication link anymore, so we remove the replication link. And then we are ready to also resize the leader node to be the same size as the other nodes in the scale-out deployment. And once that is completed, we can decommission the scale-up database because we don't need that, and the scale-out database cluster is ready to serve application and end users. And that completes the workflow to convert the scale-up database to scale-out database, all running on Amazon EC2 instances. Ramesh, do you want to speak about timeline and the planning aspect of this workflow?
Yeah, so I think like I said, we got into a sort of a muscle memory kind of thing with scale-ups. We were kind of so used to it. And then ultimately, it came to the point where for the S4 environment, we were already on a 24 terabyte system, and our growth was just outpacing the archiving that we are doing. We are archiving now. I say that with more confidence than I probably did maybe 2 years ago. But ultimately, we had to make a decision to go with a scale-out. And typically with scale-out, if you look at workloads like OLAP workloads, that's pretty common. You will see many customers, SAP customers out there running scale-out on OLAP. That's not unusual. But with S4HANA, with the old TP environment, that was a little bit more tricky. In fact, last year when we decided to make this decision, I think we had maybe 10 customers worldwide that were running on scale-out. And so when we looked at this, one of the first things we did with SAP and AWS was they were on our systems for about a couple of months looking at all the different interactions between the tables. Because what happens is with an S4 or MS4 system, etc., the interaction between the tables is much more pronounced. The chatter between the tables is much more pronounced. So what happened then is that they understood which tables were sort of interacting with each other and which were not. And then ultimately, that's how we decided, as Rutvich called them, we have scale-out groups, right? The scale-out groups are basically, each scale-out group is a composition of tables, and then that determines which tables goes to which nodes in the scale-out. And that's really, really important because if you have transactions that are going between nodes, you will find latency, and things will go, and this is real world experience, it'll go from minutes to hours to days, right? So that's ultimately why it's very, very important to make sure you get your scale-out groups right. And secondly, another thing SAP will tell you is that there are certain tables, many, many small tables, maybe that have only 18 or 20 rows. Those tables, you might think, okay, what's the big deal? You're just getting 18 or 20 rows from another node. But what we do with those tables, which are high read-only tables with hardly any changes, we replicate that between the nodes so that when a transaction needs data from those tables, it doesn't have to go across to the cross nodes. And I think those are key things to remember. And it's not a one-and-done thing. That's the final thing I'll say about this. It's not a one-and-done thing. We have sessions and meetings every month or so with SAP to re-look at the system to see has anything changed in the cross-node traffic. Because if it has, then we start moving tables around between the different nodes as well, right? So it's an ongoing thing that you have to keep working on.
Okay, thanks, Ramesh. Okay. So we'll look at one more scale-out workflow. This is different than the previous scale-out workflow that we just went over, because in this scale-out workflow, we are not actually converting a scale-up workflow to scale-out workflow. We are actually taking an SAP HANA scale-up deployment. We are carving out a segment of data, and then we are creating a new scale-out cluster with that data. So here we have an existing SAP HANA scale-up deployment. It is supporting BW for HANA application, which is primarily used by HP for reporting and analytics. And these BW for HANA application and its database are fed with three main data sources. One is S/4HANA, the other is master data governance, and last, integrated business planning. The requirement here is to create a new scale-out SAP HANA deployment with SAP IBP data segment, which is currently part of the scale-up deployment. So the first step is that we provision the scale-out cluster. This is, again, a 3 instances or 3-node scale-out cluster. We determine what instances we would need in our scale-out cluster. We created the scale-out cluster by provisioning the instances, and installing SAP HANA on them and running SAP HANA on them. And again, you will notice that these instances are placed in the cluster placement group. This is to minimize the latency. And once that is completed, we establish the data replication link between scale-up database and scale-out database. And here, we are just going to copy the data that is related to SAP IBP, so that is stored in a specific schema with all the tables that are related to SAP IBP data source. And once the data replication is completed, we disable the replication, and then we drop the SAP IBP data schema from the scale-up database, because now we already have that in the scale-out database. And we have completed the workflow by creating a brand new BW for HANA application and database using the scale-out architecture. And Ramesh, do you want to speak about the benefits of following this particular architecture pattern and workflow?
So if you think about this particular use case, you might say, well, what's particular about this? What jumps out at you? I think the key for us here was this was a data warehousing environment. And with that environment, we had multiple schemas in that environment. So you think of typical data warehousing, you can move things to the warm tier or the cold tier, et cetera, right? And SC and things like that, those of you're familiar with that. This is another way of offloading data from that environment, from the warehousing environment that we had, which is the previous one that Ruth was showing, to a small scale-out landscape, because that data that resides in that schema is kind of a little bit standalone. It's not so much integrated with the rest of the schemas, and therefore this was a good use case for us where we were able to move out and reduce the growth on the main source system by moving to a small scale-out environment. So.
Thank you, Ramesh. I'll hand it over to Vasu.
So now that we have gone over these patterns, I'll just summarize, right? Again, I think this slide is kind of self-explanatory. Now again, both scale-up and scale-out give you the benefits of additional compute and memory that you can now distribute your OLTP and OLAP workloads, right, as you need. Now, we haven't seen a case where we haven't scaled down, but I'm sure that as archiving comes in, that's one of the benefits that you can reap. Now, a couple of key considerations that we wanted to kind of reiterate. One is there is additional hardware cost, right? So please do take that into consideration from a budgetary perspective as you're either scaling up or scaling out. The instance resizing in terms of, as we talked about earlier, if you have the instances within the same AZ, it's much easier. You don't have to worry about, data transfer to different AZs if you're placing your new instances in other AZs. The cluster placement groups, especially for HA, to make sure that it's meeting the SAP required latency needs, that's a definite technical consideration you do have. Now, last but not least, there is definite increased complexity, especially in managing HA and DR for a scale-out architecture. So it's not trivial, so it's just something that you would need to take into account. Now, kind of double-clicking a little bit into HA and DR. Now, obviously, with high availability and disaster recovery, your goals are essentially threefold, right? Number one, you want to make sure that any hardware or software failure you can easily recover from it, right? So that you have business continuity. Number two, you want to protect your data, right? This is business critical data. As Ramesh mentioned, over 90% of HP's financial transactions, right, worth $53 billion, is running through these systems. So you cannot afford to lose data or have corrupt data. So that's the second consideration. The final consideration is making sure that you have fast recovery, right? That you're getting back to the business as fast as possible. So your considerations in this case are going to be RTO and RPO, your recovery time objective and your recovery point objective. So based on those goals that you have, SAP HANA and AWS provides you different HA and DR capabilities. Now what we have shown here is ultimately what HP has chosen in terms of having a hot standby for HA. It's an active-active configuration wherein the standby can be used for read-only so that it's not just sitting there idle. And then there's a warm standby system within a DR location, which is in a different region, so that you can address any regional failures. Now, Ramesh, based on your experience, is there any call-out that you have?
I would say, first, of course, with any RTO and RPO strategy, you've got to get alignment with your line of business, right? They got to be in line with the expectations that you set with them for what this would take. So with us working with AWS, we did that. And then we architected the solutions, the HA solutions that Vasu was referencing, and same thing with the DR. But HA, our RTO is 15 minutes or less. It's 4 hours or less actually, and then RPO is 15 minutes or less. But in all cases, I would say 99% of the cases, we've always exceeded that by leaps and bounds, right? We've never lost data. When we failed over, and the system has picked up on the other side. And now with Auto HA, which we've now enabled in the recent years, that's become a much quicker, non-human touch process, right? It's sometimes scary to let go of that control because for a long time, our technical guys and even our management is saying, no, we want you guys to do the failover, and we're like, yep, understood. But over time, we did it with the smaller systems first, where we did Auto HA. Showed them it could work, and it was predictable, and it was safe. And then we went to the bigger systems. And now, even for the 24 terabytes, or even the scale-out system that we're referencing, the S4, we have auto failover enabled for all of them. So,
thank you, Ramesh. Ramesh, over to you on this one.
Okay, so RISE with SAP. Before I get into the shared responsibility model of those of you, I think a lot of you know what RISE is, but I'll just recap quickly. If you think about RISE, SAP RISE, it's a managed service from SAP, but it's more than just about the platform, right? It's if you think about it high level, big picture, there are 3 core components. You have the platform management piece, which is SAP managing your technology stack and below, meaning your database, your operating system, relationship with the hyperscaler vendor. Number 2, your multiple other software contracts you have with SAP are now subscription-based within the RISE contract, right? So we had to go through a lot of work on the HP side to get there, to make sure we consolidated that. And last but not least, SAP has something called CAS, Cloud Application Service Packages. These are, you can call them supplementary or additional services they offer, which could be things like regression testing, performance testing, data archiving, database performance management, etc. They've got about a big catalog of services. It's up to you as a customer to pick and choose which ones you want. So when we looked at RISE, I think if you think about strategically why we went with RISE, I think first thing was, we wanted to get away, at least from my side and some of the other management team, we wanted to get away from sort of the day-to-day management of the systems and have somebody else take care of that, because our technical guys could then focus more on innovation and bringing in new capabilities, and like now, for example, spending the time on some of bringing up AI into our systems, on our SAP systems, right? So to do that, you needed to free up the guys from working on the day-to-day minutia of the lower-end stuff in the system. So that was 1. 2, it always ultimately has to make financial sense, right? And for us, when we looked at the TCO of what we were running our systems on AWS with our managed service providers, etc., and then when we compare that to RISE, we managed to come to a point with much back and forth with SAP that it made sense for us financially. So with all that being said, we made a strategic decision around March of 2023 to migrate those systems. We set a very aggressive timeline. I think most companies usually take about 16 months, 18 months or so. We did it in less than 12. And that's because we said for this transition to make sense for us financially, we needed to complete it within that time. So that was a big drive for us. But things to remember here in RISE, when you talk about shared responsibility, I mean, you're familiar with the term shared responsibility even in an AWS environment, right? When you have your systems in AWS, everybody knows what shared responsibility is. When you go to RISE, there's now a third player there, which is your SAP ECS team, which is the RISE team, right? So you got to understand roles and responsibilities of where your teams, your internal HP teams in my case, are still actively playing a part. Basis is still a very, very important function. People think that once you go to RISE, you don't need basis. That's far from the truth. You absolutely need a strong application basis layer to work with the ECS team. And then you also have things where you have to make sure that you continue to maintain the relationships. Like when we moved to AWS, before that we had relationships with, AWS contacts with Vasu, Rutvich, and other AWS folks. That hasn't changed just because we've gone to RISE. Yes, SAP is responsible for the hyperscaler interactions and everything else, but we still interact and work closely with our AWS counterparts. Secondly, we also have very strong contacts with our SAP HANA development support in Waldorf. That hasn't changed as well, because ultimately, when all is said and done, when RISE, when they're working through things, it's always good to have your inputs and feedback from your other partners, whether it's within SAP or within AWS, right? So I think that's key. I think what happens once you go post-go live from an operational standpoint is also very important. We have an operating governing model where we have reviews on a weekly basis with SAP, monthly with sort of my immediate upper management at the VP and higher levels, and then every quarter we meet with the CIO and above as well to review where we stand from a service delivery standpoint. It's important to have the governance in place because you really want to show the value and what you're delivering from a service standpoint. Timeline, I think what you would see this slide, right? You see it starts from 2023. So there was, I would say, focus areas here. One is we had to do some prerequisites before moving to RISE. We were on Red Hat Linux. We migrated to SUSE before that because ultimately we felt SUSE was a better fit for our HANA systems. So we moved to SUSE from a patching standpoint and everything. We work with the AWS team, and we were already in a good spot from a patching standpoint. So some prerequisite steps. The other thing I would say is that when you start migrating to RISE, you got to decide, which systems are moving when. Are certain systems moving together because they're closely coupled, ECC and what other systems need to move together. And then ultimately, in the middle of all this migration is when we decided to do the scale out, right? So we didn't plan to do the scale out as part of the migration to RISE. We were going to go from 24 terabytes on-prem to 24 terabytes in RISE. But things change, and I think all those of us who work again in this arena know that you got to be able to adapt with that. So in October, which is about 6 months after we signed the contract, we made a decision to say, okay, as part of the migration, we're going to do a scale out of S4 as well when we migrate to RISE, because ultimately we needed the extra capacity. We were running out of room on our existing 24 terabyte environment. So working with SAP and AWS colleagues like 4 or 5 days in Newtown Square, we mapped out what the solution would look like in October. And in March, from October to March, we migrated about 3 or 4 landscapes. We did it multiple times. Took a lot of work, a lot of effort, a lot of weekends, but ultimately we were able to successfully go live in the middle of March. And just in time as well, because we were literally running out of capacity on the existing 24 terabyte environment. But all said and done, if you look at the key figure standpoint, test cases, you've got to make sure your testing is solid. You might say, for us, it was a technical migration, right? We weren't upgrading. We weren't doing any release updates as part of the migration. It was a technical migration. So making sure you know what your testing scope is. Your interfaces are really, really important because network and security is a huge consideration when you go to RISE. Just like you're going to a different network, right? It's not on your own network anymore. You're on a foreign network. So we started with the model of zero trust as far as our network was concerned, and the RISE network. So we had close to 1,000 plus interfaces from these SAP systems talking among themselves and talking outward to non-SAP systems in HP, and even to vendors and to distributors. Everything that had been set up in the past 5, 6, 7 years, everything had to be recertified because as far as cyber was concerned, we're now talking to a foreign entity, a different third-party group, so you had to make sure you go through it. So what we did was, they initially wanted to go through all 1,000 interfaces, and if you had done that, I think we would still be here migrating today. We would not have finished until now. So what we did was we looked at those 1,000 interfaces and figured out, can we break them down to what we call certain patterns, right? Sort of network patterns. So what I say by network patterns is if traffic going between 2 different endpoints have the same protocols, same encryptions, same IP ranges, you don't have to certify each and every one of those interfaces. So we ended up settling in about 60 connectivity patterns that represented those 1,000 plus interfaces. We certified those 60 those connectivity patterns, and then Cyber said, okay, if any interface falls in those 60, you guys are good. You guys can go ahead and migrate. So that helped us to be able to get through that piece, I would say. Okay, so just winding up here, the lessons learned, I think if you look at big picture from a RISE standpoint, first thing is pre-migration. Your agreement with SAP, obviously, is very, very important, right? You got to be able to make sure you negotiate the best deal for your software, the services you're providing, the CAS packages, etc. Compliance is also a big deal because for us, compliance meant that we were moving our systems, the data, our source GL systems and everything were moving to a different environment. We had to show our compliance team that the data moved from source to target was 100% match, not just in terms of the number of rows, but actually that nothing had changed data-wise, right? To certify the data hadn't been modified, it hadn't been tampered with. So make sure you get those requirements cleared up upfront. We did that very early on, and that drove what we were testing. From a migration standpoint, I would say, again, I talked about testing. Make sure that, again, expectations are really important. Our application teams and everybody said, yeah, fine, you guys are migrating to RISE, but we have MTPs to production, moved to production twice a week, and big releases once a month, and other changes, project go lives, things like that. Nothing was meant to stop. It's not just because you're moving systems to RISE. No one really cares, right? You got to do it seamlessly, and you got to be able to do it without impacting everyone. So we set those expectations early on that we would do that, and I think a key success factor why they trusted us was we were able to go live. Each and every go live we did, we never impacted any releases or any of the moves to production. We were able to do everything. And last but not least, the post-migration, like I said, the operating model is really important, and your relationships, plural, not just with the SAP ECS team, with the AWS team, and the other groups you have within SAP, make sure you keep that solid and intact, because believe me, you do not want to be in a position to just depend on SAP ECS alone, because you're missing out on other perspectives and other sort of benefits you can get from that, right? Let's move to last but not least. I think we'll wrap up here. So what are we looking at next from a go-forward standpoint? We are in the middle of, we've already started the migration to SAP 2023. That's our initial, we're going to migrate we're going to upgrade, I should say, 8 systems to SAP 2023 in the upcoming year. We've done a few pilot programs or pilot initiatives on introducing Gen AI to our SAP systems. We're still learning and going on with that. But I think the key thing here is continuous improvement, right? And that's where the features that AWS is coming out on for SAP that would be keep looking at that to see how that would benefit us, because it doesn't matter that we are on RISE right now, right? We still want to leverage the same features that we had before in AWS and going forward as well in AWS, right? And that's it. I think that's pretty much it.
So with that, we come towards the end now. So we'll wait, here, if folks, you have any questions. Now, again, wherever you are in your journey, right, whether you're starting or you're already on AWS and you're migrating your SAP footprint, we hope that, we were able to share some good insights, architectural patterns, drivers, as well as lessons learned, and it was useful for you. We'd like to request a few minutes of your time, just to give us feedback, right, in the mobile app. This will help us improve and also make sure that, we are giving you sessions which were super impactful and helpful to all of you. With that, thank you. Oh, by the way, these are other SAP-related sessions which are there, right? If you want to go to any of them, please, we would love to see you there. And with that, I'll wait for you to take some pictures.
And then I think we'll be on the side for any Q&A that you might have.
Yeah. With that,
Thank you for your time.
Thank you, folks.
Thank you.